Welcome to section 3.6, our final section of chapter 3, functions. Now, as a clarity for future understanding, functions are something we're going to use a lot in this class, but really important in future classes. They're something that happens a lot in mathematics and a very useful tool. So let's just start by talking about functions, and we'll get into some other things for this. When we're talking about functions, the first question is, what is a function? Well, here is the technical definition. It is a rule that assigns each element in a set to a unique element in a second set. Okay, enough of the jargon. Let's talk about what that means. It means I have two groups of numbers, and one group is going to go only to one element in the second group. That's all that matters. The analogy that I like to kind of help with this, and then we'll do some actual examples, the best analogy is what I call the vending machine analogy. So these vending machines, similar to the vending machines we have at USM, how does a vending machine work? You put in the money, but then you press a button and you should get one thing out for what you press the button. And hopefully every time you press this, if you press the same button over and over and over, you always get the same exact thing. That is what it means for a function. So functions essentially, I'm gonna tell it I want one thing, so I'm gonna press a button. If I always get out one thing, the same thing, then I'm okay. What if I keep pressing the Coke button and I might get Coke, I might get Mountain Dew, I might get Sprite, I might get Pepsi. If I don't know, then that makes it not a function because that vending machine is broken. Same thing, a function would be broken if it has to do that. So let's look at something else that's kind of important. So we're talking about ins and outs. Domain and range is what are the keywords for that. So what are domain and range? Well, let's start with domain. And I'm using the term relation because it may or may not be a function. Relation just means there is usually two things that we have a relationship between. So the domain is typically the inputs. So it would be the button that I am pushing on the vending machine. It would be, in general, for our class, it's going to be the x values of points. So this is always the inputs. If I'm taking, let's say I'm doing something where I'm asking for a list of first names and a list of last names. The inputs would be the list of first names, and the outputs will be the last names, if that's what I'm first referring to. Now, the range, if domain is inputs, range is, you can probably guess it, it's the outputs. But also if we've taken, but think about it, if I've already used X for domain, what's left for range? Hopefully you're thinking Y's. Now you're on the right track. So anytime we're looking at things, the X's are typically going to be the domain, and the Y's are going to be typically the range. So let's use this as an example. I have 5 different points. So the first question I have for this relationship is, what is the domain? Well, think about, just back to the last slide, I told you the domain are the x values. Where are the x values in any given point? Well, they're always the first numbers. So I have a 5, I have a 9, I have a -3, and I have an 8, and I have a -6. So we can literally write all those down, but we're going to use curly brackets, this is because it's a set of numbers. Don't worry, that's just a mathematical term, but you do need to use these curly brackets to kind of surround them. That's the implication that I'm grouping them all together. Now, again, notice I wrote them in smallest to biggest. You do not need to do that. If you just want to write them as -5, then 9, then -3, 8, and -6, that's okay. This just makes it nice. Now I clicked, so let's move on to the range. Well, what's the range? It's the y value. Can you write down all the y values? Pause, go ahead and do that. Hopefully you got something very similar to this. Now notice, for instance, my -6, going back up here, it went to the 4. My -5, if I draw lines from these over to the range, every single one of these things only goes to one thing. The 6 goes to 4, -5 goes to 6, the -3 goes to the 3, the 8 goes to 30, and the 9 goes to 30. But each one of these items up here in the domain only has one line coming out of it. That's going to affect our next question, and that is this a function? So what I want you to do is I want you to pause it, and I want you to answer this, yes or no, and then defend your answer. So explain why. Go ahead and pause and go ahead and take a moment to try to think about, is this a function, why or why not? Well, coming back, if you said it is a function, you're correct. And it's because I just said every one of the domain values has only one y. It's perfectly fine that two of the x values get the same y. That's like a vending machine that has two different Coke buttons. You're allowed to press either one, they'll give you the same thing, but each one only gives you out one kind of soda, which is what we want. So let's move on, let's try this again. Here's another relation. Again, pause the video, write down the domain of that particular relation. Hopefully, when you do this, you did the curly brackets again, and you got 6, 40, 20, 40, and 60, excuse me. Notice, I like them in the nice appropriate order. You do not need to do that. But the range, what's the range? So again, pause, find the range. Well, hopefully you came back with 10, 20, and 30. And again, remember 20 goes to 10, 40 goes to 20, 60 goes to, as we look up here, goes both 20 and 30. So with that information, is this a function? Defend your answer. Hopefully your answer is no, it's not a function, because x, when x is 60, it has two different y values. So anytime an x has two y values, we got a problem. If one y value has two x's, that's okay. Just every x has to have only one y. That's the only stipulation. Okay, so moving on, not just finding domain ranges of a function, we're now going to assume everything's a function. We're going to use something called function notation. So this is understanding what do we mean when we write different things. Well, the standard function notation is this f parentheses x parentheses. This does not mean f times x. In fact, when we read this, we read it as f of x. And what it means is f is a function of x. So x is the input, f is the output. Sometimes we also say f of x is the output. It kind of depends on the scenario and what you're talking about. But we can also use g of x or h of t. So x and t are both inputs. I've even seen things that are f of y. Kind of depends on the situation you're dealing with, but g and h, big F, big A, I'll give you some examples in a little bit. There's a multitude of different ways that functions are written. So it'll become more obvious as you work with these things, but a lot of them are standard formulas actually that we use. So some examples would be this h of t. So this would be height of some time is equal to this. So t is a time, so if I plugged in my t values, then I get the height at that specific time. And I'll show you that in actually the very next section. Another one is a of x. This, by the way, is actually the formula if you have a $5,000 loan at a 6% annual interest rate that's compounded monthly, pretty typical of a lot of student loans. After X number of years, this formula would actually tell you exactly how much that loan would cost you to pay off. So how much interest and its principal it is built up to. So hopefully that helps you kind of have a better idea about how functions work and how they're nice. So let's move on to that, what I talked about, how to find some of these values. Let's do some number crunching. We're going to evaluate. Evaluate literally means number crunching. So here's your function, 3x squared minus 4x plus 5. Well, I'm first going to ask you to find f of -2. What does that mean? Well, notice my original thing was f of x, and now I have f of -2. The only thing that changed is I put a -2 where there's x. So I'm going to come over to the right-hand side of the equation, and I'm going to write all these things again, but instead of x, I'm going to replace them with -2, like so. Now we use order of operations to solve. So I want you to pause this, go ahead and simplify this left-hand side to figure out what f of 2 is equal to. Welcome back. Hopefully as you work through this, the first thing you recognize is negative 2 squared is 4. Multiply that out, and you get 12 plus 8 plus 5. Add all that together, and you get 25. So boom, we did one. Now let's do f of 4. So can you take 4 and plug it into this equation? Go ahead, pause, and go ahead and work through the whole process. Welcome back. Hopefully the first thing you do is just substitute it in the 4. Then we can square 4 and get 16, multiply things out as such, add everything together, and you get 37. So hopefully you're seeing how all these things are working together. One last example for this function, then we'll switch to a new function. What about f of 0? So pause the video and find f of 0. Well, welcome back. Hopefully you noticed that I can just plug in 0, but that's really nice because zeros squared, multiplied by anything, they make it go away, and all you're left with is 5, which happens to be the only number that doesn't have an x on it. When you're doing a function in terms of 0, it usually is the way it turns out, not always, so don't assume that. But that's just kind of a thing that 0 is often a nice thing that we like to aim for. So let's switch functions to a new one. G of x equals negative 2x squared plus 3x minus 8. So again, I want you to start off by finding g of 2. So pause the video, find g of 2. Welcome back. Hopefully you just substituted first. Notice, by the way, I'm just going to point something out real quick. I'm putting parentheses on every single one of these. I highly recommend it. Sign errors occur way more and order of operation errors when there's not those parentheses. Students forget what's the order of operations. Well, if you use the exponent first, we get to this stage because 2 squared is 4. Multiply things out, combine like terms, end up with final answer is 6. So that is how all this works together. All right, I want you to do the same thing, but now for g of negative 3. So pause, go ahead and find that. Welcome back. Hopefully the first thing you remember to do was substitute. Then you squared, multiplied, and combined everything to get negative 19. Okay, final one, g of 0. Go ahead and pause and find it. Okay, now you've had some time. Hopefully you remember like the last one, the zeros, and here notice I made a typo. I switched this negative to a positive. That means there's something wrong. So your final answer actually is negative 8 by just dropping this one thing. This is among the most common errors that you will see in this entire class. I'm not above such errors. I generally will catch them, but they do occur. So make sure you're following your negatives from step to step. So again, the answer to this is negative 8, not positive 8. Now I hope all of that helps you better understand how to work through these functions. It gives you a better idea about how to use function notation. If you have questions, please make sure you ask. Otherwise, good luck with your homework and good luck as you move on to chapter 4.